Hello, this is Xiaoming Li, and this is our CS410 project. Jingyuan Li and we made a foreign name recommender system. Our system would generate foreign names for the users, and it currently works for two different languages, Chinese and English. In the future, we might be able to add more languages to our system. So here's the GitHub link. If you go to the link, then you can see a few files. Most of them are data we generated, but there are a few Python files which are important. So in the README, you can find some instructions on how to run our system. For the setup, we have to run 4 Python files. They're called project with meaning.py, meaning functions.py, small helper functions.py, and backwards functions.py. We included a few packages in each Python file, and you have to download these packages in order to run our system. You can either do this by pip install or any other kinds of methods working on your machine. Our system considers two kinds of similarities for the words, in particular the names. The first one is called lexical similarity. We have tried two different methods. The first one is called difflib, and the second one is called Levenshtein algorithm. This algorithm actually uses a formula to calculate what's called Levenshtein distance. And finally, we found the latter works better, so that's why we chose Levenshtein. And lexical similarity, it actually agrees with high sound similarity, because sometimes we know words with lexical similarity, they would tend to share same syllables, and this somehow would achieve to generate words with similar sounds. Here's an example. So let's say if I am a user with a Chinese name called Li Ran, and because we know Chinese characters, we don't use Latin alphabet, so that's why we have to use pinyin to transfer every Chinese character into the pinyin representation. Here, Li Ran would be represented by Ran Li, like this. And our system will prompt the user to type in the number of names they want our system to generate. So in this example, our user would type 8, and then our system generates 8 names, which have very high lexical similarities with my name, Ran Li. So the second kind of similarity we consider is called semantic similarity. This would generate words with similar meanings. We also have tried different methods. The first one is spaCy, the second one is called JSIM, and the third one is from sklearn. In sklearn, we have found a very good function called cosine sim, which is able to generate the similarities of words or sentences or even documents. And because it works quite well, so that's why we have chosen the last one. Here's another example. Let's say I have a Chinese name called Li Xun. And if you know Chinese, the first name Xun actually means fast in Chinese. And then our system generates a few English names followed by their meanings. So from the meaning, you can see our system works quite well because it generates names with very similar meaning with Xun, which means fast. Like fast and swift, they all share very similar meanings. Our system would also work the other direction. If you're a user with an English name, then our system would generate Chinese name for you. So now it's time to run our system. After you download the package and also our project, then you can just go to the correct directory. Here are the files in the directory. Actually, in this folder, you can find some programs we use to generate the data. We have collected the huge data, and then we have written some programs to generate the final clean data we used for our system. Then to run the system, you have to run the 4 Python files, as I mentioned, like this. So here we have entered our system. It prompts us to type in our full name. Let's just use the example we mentioned before. Our system is smart enough to distinguish users with English name and Chinese name. So as you see, I typed a Chinese name, then it's smart enough to send greetings in Chinese, and also the color turned green here. It means it's gonna to generate some English names for us. Now it prompts us to type in the gender. I'm a male. I can either type uppercase M or lowercase m, or even the full word male. It's smart enough to understand that. Let's say I want 6 names. So you can see here, these 6 names, they have high lexical similarity with my name Li Xun. And for the second kind of similarity, the semantic similarity, because we have finally used a very huge data, that's why it would take a little bit longer to find the perfect matches. Okay, we have our results. So this is exactly the same results we mentioned in the slides. Now let's try if I am a user with English name. Let's just use some name like Swift Obama. And you see now it's using color blue because this is a second branch of our system. And let's say I want 5. If you know Chinese, you can see the results actually, they matches very well, because in Chinese in many cases we use only one character for the last name. So that's why our system also generates only one character. So this one is pronounced as ha, o, na, ma, 1. So you can see especially like o, ma, they work very well with my last name, Obama. And here are 5 results with very similar meanings of my name. And they all have meaning related to fast, because my first name, it means fast. And in some cases, because our data is not huge, it's not big enough to include your names, our system sometimes would not generate names with similar meanings. I can show you an example. Let's say if I have a name called Li Qianqian. So our system would always generate names with high lexical similarities here, but sometimes it would not be able to generate names with similar meanings. Either our data is not enough to include your names, or all the names in our data, they all have 0 similarity with your name. And in this case, our system would say, aha, your name is too unique, we haven't found any matches. So feel free to play with our system, and we might add more functions in the future. That's all for the presentation. Thank you.